Okay, we are back. Second day in a row. Second ever YouTube video. Yeah. I got some feedback yesterday on my first video. Somebody said you should try to sound a little bit more alive. Maybe like a little bit more, less monotone, I guess. So we're gonna try that. I also increased like the volume threshold on my mic. I have no idea how any of this stuff works. But yeah, we're gonna do our best. I'm gonna do my best. You're gonna do your best to actually pay attention and hopefully not fall asleep in the middle of this video. Yeah, we're gonna be making a multi-threaded port scanner for Linux, and I mean, like with all these things, I'm pretty sure it also works on Mac and like BSD and whatever Nix operating system you use. Anyway, so yeah, it's going to be multi-threaded because if you don't make it multi-threaded, one, it's really slow because it's scanning 2 to the 16 ports, and two, it's really boring if it's not multi-threaded. I mean, you're just doing a for loop and connecting to a port, right? If you make it multi-threaded, it's pretty sick. Yeah. Let's get into it, I guess. So right now, we're going to, I should show you guys what it looks like. Okay, so here is what it would look like. We're gonna have some flags to specify which ports we want. So, and here's what it's gonna print out. It's just gonna print out a bunch of ports. It's pretty much always gonna print out 631, just because that's the printer port, the internet printing protocol, and that's always open. Right now it's always printing out these 4, which is weird. I've never seen this before. Maybe this has something, this probably has something to do with OBS Studio. And then, you know, we can look at an actual Linux command, right? SS, tilde, whatever. Maybe C port 80, 6463, 631, 53. I don't know. I don't really get why that one's open, to be honest. But we're going to see why maybe later we're only connecting to this. If I do hostname -I, oh my gosh, I've never had this happen before. I have 2 host names. Oh, is this? I don't know why that's happening, to be honest. But as you can see anyway, we are printing out 4 of these ports that are listening, and then these 53, 53, 53. I don't really know what those are, right? 192.168. Let's see. If I were to do that same command again, will I get 2 host names? I don't know what that means, to be honest. If any of you guys know what it means when you get 2 host names, please let me know. Again, that might be something with OBS Studio. Anyway, we're gonna get started. I forgot where my VS Code window is. Here it is. Okay, we're gonna get started with the makefile. The makefile is just, we don't really need one, but I don't want to keep typing in it is quite a long command because we're going to be using the C++ threads, not like the regular P threads. So I'll just show you guys what this thing looks like. Here, I hope this is big enough. I realized yesterday it might not have been big enough. So we need to compile this with the pthread library. I just like using wall, and then our standard library is going to be C++11. This is because of some of the thread stuff that we're going to be using. For example, something called a lock guard for our mutex, because we will be using a mutex because we are very advanced. We are going to have a test file just to show what this program would look like without multi-threading. Just because I like seeing the speed comparison. This is going to compile our actual thing, our actual program. Let's do pscan, and this will compile to ps. And then for our clean, we're just going to do a bash command @remove, and we're going to find in this directory all of the executables and remove them. Yeah. I didn't want to do like rm test, rm ps, because then I have to redirect to like, you know, the standard error to dev null, and there's no reason for that when this works just as well, and it also looks cool. So now, contrary to what we did last time, I'm just gonna write our headers and everything out right now, because I have them right in front of me actually on my other screen, and I already know what we want to use. I don't think we're using string. While this is a C++ project, pretty much all of our code could just be copy and pasted into a C file and compiled with GCC. When I did this this past summer in July or August, and when I did it, I actually did do it in C originally, but I didn't want to do it with the P threads, because the P threads are just, I find the syntax ridiculous, right? I wanted to see, okay, maybe there is a different way to do it in C++. And when I looked up the threading in C++, the C++ 11 threads came up, and I said, oh wow, this is really easy. And then I saw the, what was it? Oh, the lock guard and how the mutexes work. And I said, okay, yeah, this is pretty cool. We're not actually going to be using cout or endl. We'll use std thread. We'll use std mutex. Here's what I've been talking about, lock guard. It's so cool, this thing, I swear. Reminds me a lot about Rust. I'm going to explain the lock guard when we get to it. Thread, mutex, lock guard. I think that's it, really. And then we're just going to declare some of our things in here. Vector int. We're going to have the vector of open ports, and we're going to have a mutex for that vector. Okay. I'll write the test first, actually. This should be pretty cool. So if I just include pscan.hpp. So here is going to be our main function. We're not going to take any arguments like we saw with the actual one. We're just going to get the number of threads. Wait, I don't need to do that because I was already using that. There we go. Oops. And we're going to printf. This is going to show us how many threads we have, and also just do it like without using those threads. So here is our scanner function. It's just going to iterate over all 2 to the 16 minus 1 threads, which is 65535. Okay, and then this is just pretty boring stuff. It's just the boilerplate code, I guess you could say, for connecting to a socket. So inet ptone. We're using the AF inet. We're connecting to ourself. and we're doing and tower.synAdder, and if that is less than 1, we'll just say we ran into an error or something. I don't know. Oopsie. Here we go. And exit. Alright, so that's that. Now we gotta just set all the memory in the tower struct equal to 0. I'm making a lot of typos right now. Okay. Then we're just gonna set some of these things. Equals AFINET tower.synAdder.sadder equals inet adder of ourself. Okay. And tower.synport equals htons of I. Okay. Do I not have memset? I don't understand. Oh, memsets and string. That's like, I really thought that was in, I don't know, uni standard or maybe standard library. Okay. There we go. Why is this in, I guess I can understand why it's in string, but there's the fact that it takes a void star, right? It should be knowing, you know, we might not get a string, we might get literally any pointer at all, and we're just gonna set it equal to whatever. Who cares? It doesn't matter. I'm not qualified enough to criticize the people who make the C header files. Oof. PFINet. I don't really have much to say about what I'm doing right now. I feel like if you've done this once, you've done it possibly a million times. It's all the same. This just means that it failed to create the socket. We're just going to continue. I'm not even going to bother printing something out. Otherwise, if we were able to create the socket, then we're going to connect with the sockfd to, oopsie. I want that. I want to cast this to a sockadder star. So then we're going to push I onto the vector, and then at the end close sockfd. Alright, why is my CPU usage going crazy right now? Jeez. Alright, it's slowing down now, I guess. That was pretty weird. Anyway, so yeah, this is it. This is the slowest version we can make. So, let's just cat that. Yep, looks good to me. There we go. I zoomed in for you guys again. So we have 8 threads on this machine, and it took a while. Let's time it. Took about 2 seconds, I'd say. Yeah. We can do better than that, right? Time it again. Let's repeat it 5 times. Right, about 2 seconds each time. Yeah, alright. So we'll just say on average it takes 2 seconds. We will close the test file now, and we're going to, let's just make clean and clear the screen. We're actually going to start writing our C++ file, or the one that we're actually going to be using. So we're going to include, there we go. Now what I'm going to do first is print our help message. We're going to see when we throw the help message in a second. It's pretty much just, oh boy, what did I do? Okay. Sorry about this. We're just going to throw this help message whenever we input something incorrectly. Or we're going to have an option to show the help message. So we have system ports, we have user ports, and you guys can look this up online, like which ones are the system ports, which one are the user ports. And then we also have private ports. And then we're also going to have an option to scan all the ports, which is, you know, what I normally do. And then of course we have the option to print this message. Alright, perfect. That looks good to me. I'm going to go down to our main function now. That's not a car, it's a char. Car star, argv. Oh my gosh. Oh my gosh, I keep spelling it wrong. Oh man. Alright, so what we're going to do in here is really quick error checking, not going to be too crazy about it. I mean, there isn't really much we can do, right? We're just going to say if we don't pass in any arguments, right? So if argc equals 1, I like using the modern C++ or stuff. I just think it looks cool. So if we only pass in one thing, or we're going to compare the first one to just a dash. We'll just do the help and turn 1. There we go. Otherwise, everything should be fine. We should have at least one of these flags. I originally over the summer also wanted to do something where we had multiple different flags. Like I could specify S and U, but I don't know, I just didn't really feel like that. If you want S and U, you might as well just print all of them and know the user and the system ports. I feel like if you're specifying them, you know like where the boundaries are for them, and you can break it up yourself. And plus that kind of stuff is just not that fun for me. So we're gonna use our getopt stuff, super. Okay, there we go. If we specify S, if we specify U, if we specify P, H, default. Okay, so this is just what's going to happen, right? H will fall through into default. We would have the same code here anyway. S, the system ports are the first 1024 ports. So we're going to say start is this and end is 1023. And we're going to call our thread handler on start and end. and then we're going to break out of this. Here it starts from 1024 and it ends at 4951 something, 49151. And again, thread handler on start and end. Here start is going to be 49152. And end is going to be 2 to the 16 minus 1, which is 65535. Thread handler on start and end. Oh wait. I was just thinking I could have probably had the break before thread handler and then just move all of the thread handler function calls down to the end of the loop, because here nothing else is going to happen. But that's okay. So we're going to have void thread handler. It's going to take int start, int end. And as we saw before, we're going to have max threads equal thread hardware concurrency. And we're going to keep a list of our threads. Oopsie. And obviously we're going to have that many threads, so we would have a list of 8 items. Now we are going to have our interval size. And now here is the fun part, in my opinion. When I came up with this, I was very happy. We're just going to have all 65,536 ports all split up into 8 different groups for my computer, right? If you're running on a PC with, like, I don't know, 12 threads or something, you would split it up into 12, right? Just like this. So we're going to have end. Let's say we're running all. We're going to have 65,535 minus 0 plus 1. So we're going to have 65,536 ports divided by 8. And each thread is going to do that many ports. And we're going to have each thread operate on a block. And then all the blocks are going to be next to each other. So we're going to have int thread num. And so now for here is the little math part to this. So our right bound is going to be start plus interval size, and then we're going to call the C++ thread function on this thread. Well, not on this thread. We're going to set this thread equal to the thread that is returned from the C++ function. So we're going to count open ports, start, and here is our right bound. Right. So here, yeah, that's fine. We're going to define count open ports in a second. It's just going to be called on. It's very similar to pthread. If you've ever used pthread, we just give it the function and some arguments, right? Pthread, I believe, takes the address of the function in memory. This, you just need the name of the function. You don't even need parentheses, just the name. I bet in like assembly, it'll know to look for this as a function. Whatever. The compilers are much smarter than I am. And then we're going to set our start equal to right bound plus 1. This is what I meant when we said we are operating on all of the blocks next to each other. So the first thread is going to operate on the first block, and then we have that right bound set up from here, here. And then we set start equal to the first port in the next block of port numbers, and then the next thread will operate on those. And so then we're going to have for each thread T in our thread list, we're going to call t.join, right? Can I not do this? Let's see, maybe if I define count open ports, if this error goes away. I just thought I could use a for each loop instead of a regular for loop. But, okay, so that goes away. This doesn't for some reason. Do we have a quick fix? No. What? Whatever. It's kind of sad, to be honest. There we go, same for loop as before. And then we're going to call thread list of thread num dot join. Okay, so that works. I don't really get why the for each loop didn't work. I can't really complain though. So actually what we're gonna do, instead of typing this whole count open ports thing again, we're just gonna copy this scan function here. So we have our int sockfd. Why don't these things get indented right? Int I equals start. Oh, we can actually move this out of the for loop. It doesn't really make sense to be here. So I was wondering what was wrong here. And then for int I equals start, I less than and I plus plus. We can move all of this out as well. Wait, no, we need that, but we can move all of this out. There's no reason to continue doing all that. Yep, so we do tower.synport equals htons.i. We try creating the socket. If we can't, instead of just quitting, we can just do, we will print something out for the actual function. Failed to create socket for port this. Trying again. And it's going to take I. Okay. Otherwise we close the socket. Let's just do I minus minus so that when we go through the for loop again, we try again. And then we continue. And then if connect sockfd, if this equals 0. Okay, here's the thing, right? Here is where we use the lock guard mutex. So we're going to call lock guard with the mutex on our vec mtx, right? And then we push this back onto the vector. Now this is because, let's say two things are trying to push onto the vector at once. This will just prevent any race conditions. I find it very unlikely that out of these 600 almost 70,000 different ports. 2 threads will try to, push something at once. But just in case, we're going to do this. And here is how the lock guard actually works. It's pretty interesting. I'll just read it first. When the lock guard object is created, it takes ownership of the mutex it is given. And then when control leaves the scope in which the lock guard object was created, the lock guard is destructed and the mutex is released. So it seems like whenever I see something in a language like this, like C or C++ or even Rust, I try to imagine how it works in like assembly when this thing is actually compiled down. So it'll like grab one of the permissions of the vector mutex, and then the compiler will see, okay, it's going out of scope now. It was declared inside the scope of this if statement. Once it reaches this bracket, it's out of scope. So before we exit this if, we're just going to release the vector mutex. We can see an example here from them, right? We just have a integer and we have a mutex called gi mutex here. We declare the lock guard and we lock it on here. And then we use the gi variable or whatever. And then the mutex is released when the lock goes out of scope. Where are the member functions of this? Sorry. Scoped lock, it looks interesting. I actually didn't see this before. But that's C++ 17 and we have C++ 11 in our makefile. I wonder, here it calls a lock. I call guard. I just realized. What's the difference? Whatever, what is this? Here it calls LCK. What is LCK? Dude, where are the functions on this? I don't know. That's weird, but either way it works. So then we'll close the socket FD, and then here we join up all the threads, and then we're gonna actually sort the threads because they'll probably be not in the right order. We're just gonna sort it in increasing order. We're gonna call our print ports function. Scroll up, inline void, print ports. We're gonna do %s, %d, %s, \n, and we're just gonna highlight it in a bold white font. And then we're just gonna reset it back to normal. 0. Alright, this looks good to me. Let's make PS. Okay. Call it on. This isn't good. Why did this happen? I bet it's because I didn't put the break. Oh, I just don't even have something for A. Okay. Start equals 0, end equals 655, 3.5. And then we break. Oh, the help message should print another new line. There we go. PS is not up to date. So we'll just make clean. Don't know why that's happening. That's significantly faster than what we saw the original non-multi-threaded version do. So if we time it like that, half a second. Let's repeat 5 ps-a. I meant to time that. Yeah, it takes about half a second. Okay, maybe a little bit more. Let's time it again. Yeah, it takes about half a second. It seems like obviously when it has more, it takes, you know, a significant amount of time longer. As you can see here, right, it has 5 ports here, and here it has 6, and it takes almost a full 0.1 seconds longer. But then here it has 5 again, and it takes 0.611 seconds. I don't know. That's weird. But either way, if we repeat 5 time, oh, I forgot. Then if we repeat 5 time test, see, it takes almost 2 seconds. So we're cutting it up. So 2 seconds to half a second is what, like 4 times faster. I think that's pretty good. But anyway, yeah, that's it for this video. If anybody knows a better way to do the port testing part, I would like to know. I'm into this networking stuff in C++, and I'm starting to get into it with Rust. But if anybody knows how to do it in C++, please leave a comment. If anybody wants to see a different video, has a recommendation for something I should do, leave a comment. Don't forget to like, comment, and subscribe. Share the video, send this video to your friends. You know, say, hey, let's make a multi-threaded port scanner. But yeah, that's pretty much it. See you guys in the next one.